Okay, let's look at 3-8. So 3-8, we have a 20 cubic foot tank. Temperature equals 100 F, and pressure equals 200 psi in the tank. And it's some paraffin. We don't know what it is. So unknown paraffin gas is in there. So we add to the system 10 pounds of ethane. And the mixture is measured specific gravity equals to 1.68 when you have that final mixture. So now we're going to have to work let's see. Now we're going to have to work our way backwards here. So partial pressures. So P equals P of A plus P of B. So one of these is ethane. So we got to figure out what our partial pressures are. So 10 pounds and 20 cubic feet, we've got to calculate. We'll use M equals P big M V over RT. So we know this mass, we know that equals 10 pounds, because that's what we injected. We're trying to find the amount of pressure, is what we're trying to find out. Partial pressure of the ethane. So 30.07 is the molecular weight. You can look that up in Appendix A. Our volume is 20 feet. We're going to divide that by 10.732, which is R, and the temperature is 100 F. We're going to assume a constant temperature here. So assume constant temp on that. So 100 Fahrenheit plus 460 is 560 R is our value. So we rearrange that and we can calculate pressure would be equal to, in this case, 100 psi. That's the partial pressure. We solve for it here of ethane. So total pressure equals the original 200 plus 100. That's going to equal to 300 psi. That's our total pressure. So now let's look at our partial pressures. So as we know from Dalton's law, the composition of component J is the partial pressure of J over the total pressure. If you want to do it that way. So the partial pressure of the ethane that we just did is 100 divided by 300, and that's equal to 0.33. Continued, and because things have to add up to 1, our unknown component is 200 over 300, which is equal to 66 run on. So we know our compositions up there. Let's leave that right here so we can see that. Now, moving right along, we want to know our apparent molecular weight of this mixture. So the apparent molecular weight is equal to the summation of Y sub j times the molecular weight of component J, right? So in this case, that's going to equal to 0.33 times molecular weight of the ethane is 30.07 plus 0.66 times our unknown, we'll put X, molecular weight. So we're trying to solve for that as part of this. So the specific gravity of the mixture, we already know is 1.68, right? At standard temperature and pressure. So specific gravity, we can figure that out by air. So this MA is going to be equal to specific gravity of the gas times the molecular weight of air, which is 29. This is for air. We can find that in the back table. That's going to equal 48.72 would be our answer. So rearranging this, we're going to get 48.72, and then we put this down here equals to this times 30.07 plus times mx is what we're looking for. So now we need to solve for mx. We rearrange and solve for that. We'll get mx is equal to 58.05. If we go back into Appendix A and look up what has molecular weight of 58.05 roughly, we will find butane. That's a paraffin. So the answer is butane. This was a butane-ethane mixture.